So, as people are coming back, we're slowly starting again. I hope you enjoyed the well-deserved coffee break. There was a lot of content so far that we covered. We still have a bit more with us. And I have Aditya with me who will talk about HANA memory sizing predictions and how to optimize them. So, Aditya, stage is yours.
Thank you so much. Hello, everyone. My name is Aditya. First of all, a warm welcome to all of you here in this room and also to those people who might have joined us online today. Um, so, okay, so before we proceed, yeah. So we are here to discuss about how to optimize HANA memory sizing predictions. But before we understand the predictions, we need to estimate first. Yeah. Um, I have, first of all, a big fat disclaimer. I'm not SAP employee. Uh, However, I have spent nearly about 19 years now in this SAP ecosystem. So I do have certain learnings and experiences that I would like to share today. Yeah. Okay. So why should we do HANA sizing estimations? Yeah. Often when managing HANA without proper estimations based on some rough guesses, it reminds me of the challenges um, that one could encounter organizing an Indian wedding, for example. Yeah, because Indian wedding has this secret power. Uh, the guest list expands on its own. Yeah, and you can't do much about it. That's a typical cultural thing. But then again, for the guests, it's fantastic. You know, it's great fun, lot of celebration, music, and then dancing, whatnot. But for the organizers, it would be a logistical nightmare. Yeah. So maybe for the Indian wedding, it is okay because it is once in a lifetime event. But when it comes to HANA administration, it's our day-to-day business. Yeah. So we need to look to defer the surprises as much as we can, if not completely avoid them. So let's have the look at typical pitfalls, the typical surprises one could encounter if you don't have proper sizing estimations. Yeah. You would encounter, all your memory occupied by your column store, for example, or maybe some performance issue uh, with some unexplained reasons that you could not figure out. Great difficulty, you will identify a custom code, you go to the developer and he says, no, nothing is changed. Yeah. Of course, nothing is changed, but the surrounding environment keeps changing. Yeah. This is what I keep trying to explain the developers. Yeah, nothing is changed, but things may not work as before. Yeah. Now, as a result, you will land into a typical HANA out of memory situation. Yeah. And then what happens? You need to scale it in an emergency manner, leading to some unplanned downtimes, and then, needless to say, budget deviations. So, which options do we have normally when we talk about making some sizing estimations for HANA? Okay, some t-shirt rules, maybe quick sizer, okay, a web sizing report, or maybe a combined approach depending on which phase of project you are in. Yeah, of course, they all are good options depending on the context, depending on the situation you are on. However, they are just meant for short-term plan. Yeah, people tend to rely on these results for long-term, ignoring the need of sizing estimations. But the key part here is the assumptions may change. Yeah. So how to tackle the change in the assumptions as the business keeps running on your HANA systems? Let's have a look at the possible limitations with the options we have. Let's talk about fixed sizer. It's based on static assumptions, first of all, very initial stages of the project, simplified data growth estimations, absolutely no considerations of data tiering and other niche technologies that would allow us to reduce the memory. And it is based on some standard scenarios, like, It relies on certain benchmarks that you might be aware of. Yeah. Now, when it comes to the above sizing reports, it is still not a bad option. However, it has its own pitfalls. No complaints on that whatsoever. Now, it focuses on the disk-based projections with certain default working memory assumptions. Yeah. It always considers 100% of your column store as a requirement for working memory. That could go right or wrong depending on how your working memory is operating. Yeah? So here is a snapshot of a above sizing report result. You could clearly see where I have indicated that it considers 100% of your working memory, and this is usually ignored when consuming these results. Now, then how should we fix this? Yeah. So first of all, let's accept the fact that sizing iteration is not just one-time show, but it is an iterative process. Yeah. You start with analyzing your data volume footprint. When I say data footprint, I'm referring to the footprint on memory. You look for options to housekeep the data to reduce the memory footprint. If that is not possible, you look for options for data archiving. It's a long, tricky route in practicality. Nevertheless, it should be considered. Then data tiering is our another savior, I would say, for some quick savings. Now, until here, we are only targeting 50% of the HANA sizing. Now, the Pandora box, getting revealed. The working memory requirements is really the one that would be the dominating factor in deviating the sizing estimation. Now, if you understand your working memory requirements trend, then there is a possibility to optimize that. Yeah, we will look into these parts step by step, and we will see how we can make some better predictions. So, when it comes to analyzing data footprint in memory, there are various options available. SAP always overwhelms us with multiple tools. I found this as a most viable option. Yeah, Martin script. It's accessible from your SQL HANA SQL statements collection. So here, the highlighted part, I am trying to understand what is loading onto my memory. I'm not bothered about what is occupying as a top table at the disk level. Yeah, of course, usually maximum 100 top 100 tables make up 80% of your data footprint. Yeah, it depends on the business case. Yeah, from case to case. So you try to understand what by looking at the top tables and how much it is contributing to your overall footprint. But the catch point here is always target at least those tables that cover 80% of your payload. Okay. Now, I have a sample output for you. So just I filtered only the EDI tables. You have this EDID4, EDIDS, whatsoever. What is interesting here is obviously my top one. So in the subsequent slides, I will take this as an example to explore the options to reduce the memory footprint. Now, here the catch point to understand the inflow impact on the memory is you should focus on the maximum estimated memory. Yeah, in the sense every table will have this maximum estimated memory auto-calculated by HANA, and it is visible here in this output. However, sometimes it could miscalculate. So the safe route is just discount the LOB disk portion out of the overall disk size, and that makes up your maximum estimated memory. Now, when you divide the maximum estimated memory by the number of records it has, you will get to know what is the individual record size at the memory level. Now, I understood my memory size of each record. Fair enough. The next part is to understand the time profile of the data, in the sense how the records are flowing in on a daily basis or a weekly basis. In this example, I chose a representation for a weekly analysis. Also, there are multiple tools for this. You could consider HANA analysis. Yeah, that would nicely build the histogram for you. How many records are present in the table for what period? Now, in this EDA D4, the LOB portion is 0. I have my disk size of 188, blah blah blah, and then some X number of records. So I calculated my record size. It's coming up to 93 bytes, for example. And then I also have the number of records coming in, roughly up to 6 million, looking at the last, I don't know, some uh, 8 weeks, maybe. Yeah. That is good enough. You could discount 1 or 2 spikes. Yeah. You have to see what is the average inflow. Then my data inflow memory estimation per quarter, for example, will be like memory size per record into how many records are flowing in per week, per day, into the time profiling factor. Like, that matches to the quarter. In this case, I understood I have around 6.2 gigabytes of memory getting occupied on every quarterly basis. Okay? With me so far? Now, I just kept this data outflow just for the sake of completeness of the slide. But if I don't want to go into the details of how to do archiving and housekeeping. My intention is be aggressive on your residence periods. Show the inflow patterns to your stakeholders. Ask for meaningful residence period. Having a residence period of 3 years for a finance data doesn't make any sense. Yeah. So just out of apprehension, you are maintaining the data. But on top of that, even if you target some 100 records that qualify based on your residence periods, would not be removed completely. And this happens especially with respect to your functional tables, the so-called business tables. SAP says, for example, the AC DOCA cannot be optimized with data outflow more than 70%, which is the so-called success rate. So you have to start understanding what is the success rate that is coming out of your archiving or housekeeping efforts based on how many records are actually getting rid of your database. And then you could find this information from SARA or maybe the jobs pools itself of the respective housekeeping or archiving mechanisms. Then you need to understand what is the residue, how the data is getting accrued over time, and that is usually a surprising factor for us. Yeah. Now let me try to make a calculation again in the memory context from a data outflow perspective. It goes in the same lines basically. So you have the memory size per record already that you have known, and then you have the actual number of records that are getting reduced, where into how many weeks you want to calculate it for. But stick to one time period so that your estimations would be in a consistent manner. So for my example, I took a quarterly representation. Yeah. Now comes the data tiering. Again, I took the same EDAD for example. So what you need to look for here, the so-called NSE savings factor. In the sense, when you enable NSE for any table, what you need to look out for how much data is paged out, means tied out from the expensive memory to the less expensive disk area. So how did I achieve this 183 GB? Yeah. Basically, I had 97% of savings from my memory footprint. Great. So how did I achieve this? I applied at the whole table. Yeah. Usually, technical tables are reasonably okay to consider the whole table for NSE, but it also depends on the cases. Yeah. Now, with that, only 3% is left out in the memory. So my job is to make this calculation on what I already estimated before. Okay, then let's come to the estimated data footprint on the whole. So I have the data inflow per quarter minus I have the data outflow per quarter plus, let's not forget, I have some accrued data. And then it makes up my estimated data footprint. But that's not it. We still need to apply the saving factor that we achieved from the NSE. So you simply multiply it with your saving percentage that is coming out of NSE implementation. That is your final data footprint estimation. So until this point, we have understood 50% of the HANA sizing requirement. Now, the remaining 50% comes from the working memory. So nobody knows what the memory utilization would be like tomorrow or even the next second. Yeah. So you need to build the trend to understand the average utilization factors. Again, I am relying on Martin's script here. So I'm just focusing on the heap area. Yeah. And the output would be looking something like this. So just by looking at this trend at the whole calendar week level, let's say for 2025, for example, so I know my dominant factor is coming from my statement executions, followed by heap cache areas. Yeah. So statement executions, it could be a custom code or sometimes a standard code operating on a CDS view or not. When it comes to, sorry, I said heap caches, but I wanted to refer heap system. Now, heap system could be any intermediate table, a translation table trying to map to the value IDs, yeah, or it could be, let's say, the heap area occupied by your disk LOBs. And even disk LOBs have to be loaded onto the memory, which occupies certain area in the working memory. And you could consider playing around with your garbage collection parameters if you want to make some optimizations. Now, so after understanding the trend analysis, after understanding the dominant factors, it makes sense to look into the optimizations. Yeah, short-term actions, always consider what SAP is recommending. Yeah, in terms of setting the global limits, at least you would avoid a potential out of memory situation with that. And then continue to monitor your expensive statements and define individual workload classes if necessary. Yeah, but for long term, here I took some S4HANA examples. You have to consider optimizing your SQL statement, maybe with hints, maybe with some other mechanisms that we have learned so far today. One thing I can already tell you, be watchful to this NSDM, new S4 data model. It comes with certain CDS views that are not apparently visible from the application side, but somebody tries to hit a table like Marcy, it kind of redirects at the database level, makes the execution times longer, the memory utilizations higher than what you expect. Yeah. So now you already have the working memory trends. You could make use of that to build something called workspace ratios. So you have the working memory and you have the data footprint. So you simply divide the working memory with the data footprint, you will get the workspace ratios. So what SAP recommends based on ABAP sizer output, 1:1. Yeah. So here I have set myself a baseline that I should play under 1:1. Okay. But you cannot size any system for 100% utilization. Start with 95% utilizations, means 95 occurrences out of 100 makes my 95 percentile. So at a 95 percentile, I am playing at 0.56, means if I have 100 GB of data footprint, I would just need 50 GB for my working memory instead of our previous assumptions of another 100 GB, simply wasting your expensive HANA memory. So now we got the estimated data footprint with NSC effects. Yeah. Now we need to apply the workspace ratios factors on top of that. In the sense, now to be on a safer side, I took the last 12 weeks average, yeah, which is up to a quarter. Okay, not a bad sampling. And then finally, your estimations, or rather the predictions, would look something like this. Yeah, if you go with standard ways of making HANA estimations versus an optimized way of calculation, yeah, with considering the NSE effect and the workspace ratios as factors, you would possibly save a lot of memory and also some budget. So the key takeaways, yeah, with proper estimations, I know my hardware is ready. I can make better planning. I understood my scalability. I know when I will hit my scale out architecture. Yeah. My performance is reasonably under control. Yeah. And like I said before, my architecture is sufficient. Of course, it will also enable you to make some efficient budget plan. You will bring some transparency to the management, which is never an easy task. Yeah. Okay. Then some key takeaways. First of all, HANA sizing analysis is not a silos activity. It often requires various collaborations with multiple teams to gain the right information and to make the estimations. Number two, working memory is a moving target. So moving targets can only be monitored and controlled. Then you have to repeat this iterative process as you need. Yeah. Maybe whenever you have some major changes, maybe a HANA upgrade, it could bring surprises that you're not aware of. Yeah. Or maybe an application upgrade, or for example, any such events. Now, continue to review your inflow and outflow patterns and also the data tiring saving ratios because they keep changing for an year and you cannot afford to ignore this part. This is how you could target the variations in your assumptions and improve the accuracy of your estimations. Now, there are many other options to reduce your memory footprints. For example, if a table has a var binary column, you could consider converting it to a disk LOB column. That would bring a lot of savings, but it comes with a cost. So you have to see what works in your favor when you make certain changes in terms of performance. Yeah. So I did try my best to share my experiences about this vast topic in a very short time. But this is something I have learned with various collaborations with multiple experts over time. But if you have any questions, feel free to connect with me in the expert corner. I would be glad to help you. Yeah.
I actually believe we have time for at least one question. So if there is one, I could throw the box towards you. If not, Aditya, as you said, you will be in the expert corner. Anyone? All right. In that case, Aditya, thanks a lot for all these insights. Super insightful to me also about memory sizing recommendations.
Thanks a lot.